Hello, my name is Sowmyan Rajagopalan, founder and CTO of Thalia Design Automation. In today's presentation, I'll talk about the issues faced by semiconductor companies, including foundries, during the reuse of IPs. I will go over three case studies of Thalia's AMALIA technologies, essentially addressing three different market segments. I'll also cover the benefits that these technologies bring about during the IP reuse effort. This is a classic decision fork that every design company faces. Focus on building new IPs or also focus on building a portfolio of these IPs. There are advantages to each routes. So with the new IPs, the advantage is that you start addressing new sections of the market, you are increasing the revenue exponentially, hopefully, and it's exciting. Designers like to work on newer, better designs. On as far as the other aspect is concerned, building a portfolio, it allows the company to expand in the existing market, stabilize, and also increase their revenue. The key aspect here is focus on designing of new IPs or the reuse. The problem is it is not an either or situation where it's one or the other. In most cases, you have to do both. But with the issue of limited resources and all those things, it becomes a bigger issue. We'll talk about this in the next few slides. When you look at analog circuit design, you see that it is impacted by a number of factors ranging from device performance, process technology characteristics, market needs, and finally the design methodology deployed within design companies. So this essentially makes moving a design, reusing IP, almost a redesign. So even a band gap is no longer just a tweak, but it's more of a redesign. Add to this that there are limited usable solutions in the marketplace and a shortage of good analog circuit designers. So this actually makes a difficult problem worse. So hence this begs the question, is efficient analog IP reuse a myth or a dream? Now let's look at the need to migrate chips or IPs. So here in this case, on this slide, it's about IP vendors and tier 1 players. So as the functionality of the modern applications increase, the need to fit in more transistors with expanded capability and functions into a chip increases and increases exponentially. The key driving force for process node scaling is the Moore's law, which aligns with the market needs. That is, fitting more transistors for a given area. This means that developers of chips have to constantly keep moving towards a technology node which aligns with the market needs. So it is not the case of if you want to do it, you have to keep moving your IPs and chips to a different technology node. Obviously, there are other benefits to moving the chips or IPs to a smaller or a different node. They are lower power consumption, better performance, and newer markets. In the previous slide, we looked at the need to migrate IPs from an IP vendor and tier 1 players point of view. On this slide, we look at it from the foundry's perspective. Obviously, as you can see on the screen, there are different sets of nodes with different sets of foundries, and the motivation is to make sure that these nodes and technologies are best aligned with the market requirements. That is, new functionalities being delivered by the right set of process technologies and nodes. The key aspect here is the better a process technology is aligned with the market need, the more cutting edge it is, the more cost effective it is, the higher the probability of the end customers, the IP vendors and tier 1 players, to use that specific process node or a technology. So it is a big motivation from a business point of view as well. So the next slide, we will look at various different factors that impact the decision making process when it comes to IP reuse, and then we look into how Thalia, with its technology, how it would how it helps these IP vendors and tier one players in cost effectively and efficiently moving their IPs from one node and technology to another. Now let's look at the various different factors that one must consider before embarking on reusing an IP in a different technology or a different node. Um, when you start off with looking at other foundries, other technologies or nodes to move your IPs into, the first thing is the characteristics in that specific target technology or node. So, the unique aspect about it that could improve the functionality of the existing IP, something that results in lower noise or lower current, for example. Now, the second aspect is the compatibility, the similarities between the source and the target technology. If the source, for example, a 40 nanometer technology is not going to be that compatible with a 130 nanometer technology, and lesser the compatibility or lesser the similarity, higher the cost. So that's where the third bullet point comes into play. What is going to be the cost to design the IP in a new process node or a technology? A very different a process node or a technology, the higher the cost to develop the IP. And obviously, higher the cost to develop the IP, it means that more licenses needs to be sold to recover that cost, which obviously is going to be one of the key determining factors. And the last one is the market need. What is the market requiring of a specific application? And if the market is headed in a direction where it's moving into a specific foundry or a technology, the rest of the platform has to follow. So all these things play a big role in determining the reuse of IP. But the key aspect here is that one needs to look at for specifically companies that are reusing their IPs and also foundries. Is there an efficient way by which these IPs could be reused? Yes, there are a number of variables, but is there a way to address these variables and provide that confidence to the user base? We'll look more about this aspect in the next few slides. The last few slides, we saw various different motivations to move a chip from one node or a technology to another, whether it is the foundries or the IP vendors or tier one players. Given the high costs to design an IP in a new process node or a technology, it's paramount that the end customer, IP vendors or tier one players, have clear understanding of the advantages and disadvantages from a cost and effort point of view of selecting a specific process technology or a node. And this is where the AMALIA technology analyzer adds immense value. This software takes a design centric approach and it looks at all the first order and second order effects of the devices in both the source and the target technology. It does the analysis, presents the results to the customer in the form of a report, and this report could be analyzed by the end customer and could make a judgment call on the pros and cons of a specific technology or a node. And this also helps with the planning process on the cost, the effort, and the amount of time it would take to get an IP redesigned in a new technology. The key thing here is if a circuit is reasonably comparable to the circuit before migration, the chances of this circuit post migration working with a minimal number of iterations is high. And lesser the number of iterations, lesser the cost of reuse. And this is something that AMALIA technology analyzer can help the customers with. So I'll go over three different use cases of the deployment of the AMALIA technology analyzer. On this slide, you see a case study of an audio amplifier which was migrated from 40 to 22 nanometers. The circuit is a four-stage amplifier, and this failed during this migration process. Some of the key specifications were not met. As you can see on the screen, the gain values had a big variation over corners and in some cases dropped steeply. The first step in the process of fixing an issue is identifying the root cause of this failure. We deployed the AMALIA technology analyzer to compare the technologies and understand the differences in electrical characteristics. As you can see on the screen, the VDSAT min value was different between the technologies, and this pushed some of the devices into triode region. With this knowledge of why the circuit failed, the design team was able to fix the circuit with a new topology, and as the curves show on the screen, the circuit was able to meet the requirement. This is an example of how the technology analyzer is deployed during an IP reuse effort, and its capability of comparing the differences and between the source and target technology could be leveraged in making sure that the circuit is migrated from one technology to another correctly. Now let's look at the second case study. It's about selecting the right set of IPs for a specific need. Now here in this particular case study, it's about a customer whose SoC operates in 90 nanometer. They don't design all the IPs that is required for this SoC, so they are in the open market looking for IPs to complete their SoC. So here there are four potential options: 40 nanometer Foundry 1 and 2, 65 Foundry 3, and 130 nanometer Foundry 4. Now the question is, 130 could be cheaper than 40, but it might have so varied electrical characteristics than 90, it might be too much of an effort. 65 could be easily sourceable, but it might not have all the devices as 90. So the question is it Foundry 1, 2, 3, or 4? And this is where Thalia is able to help potential customers. Using the AMALIA technology analyzer, we are able to compare, analyze the technologies, and able to help the customer in accurately analyzing and choosing, and in the process facilitating the customer to choose the right sort of IP for their need. Now let's look at the third use case. This applies to both foundries, listed at the bottom left, and to customers that reuse IPs. Could be IP vendors or tier 1 players. Now, once the customer has identified the source and the target technology, they would be able to deploy the AMALIA technology analyzer and understand the similarities or differences between the source and the target nodes and technologies, and better plan the reuse effort. And in the case of foundries, they would be able to help their customers in migrating designs into their fab. A Foundry 1, they could help their customers and move chips or IPs in, let's say, Foundry 2 to Foundry 1. And this is something that foundries could offer as a value to their customers. So as this use case shows, this capability here, AMALIA Technology Analyzer, is something that the foundries could deploy for their customers, and the IP vendors and tier 1 players could deploy it for themselves in deciding and planning the technologies from which they have to migrate to, and also the technologies they want to migrate to. I founded Thalia back in 2011. The primary motivation was effectively to bring about an improved efficiency and hence reduction in the costs in the design and reuse of analog and mixed signal IPs. Um, the last several years, we have become partners of choice with companies like Katina, now NXP, and Dolphin Design. We've expanded the capabilities within our portfolio, the tool sets and the technologies we have, and we have addressed varied applications all the way from baseband to high gigahertz applications. Why are we unique? Thalia are bringing about a paradigm shift in the way analog IPs are reused. In our case, what we do is we don't just focus on tool sets or on manpower resources. It's a combination. The first in this section are our proprietary or revolutionary technology, which addresses all aspects of the design flow, the schematic design and the layout, and it comprises of AI algorithms. The second comes here in this place are the methodologies that we have in place, which effectively define how you go about analyzing a technology, when you deploy automation, and where you deploy the technology. The last bit here in this combination is the smart resources. Certain aspects of analog design can only be addressed by experienced resource base, and that is what we have. It is this combination, which we call the trifecta, which is a differentiation between us and the rest of the marketplace. And it is through this we are able to bring about improvements to the efficiency, hence the reduction to the costs when we when we deploy this on IP reuse engagements. There are four components within the technology section of the AMALIA IP reuse platform. The first one is the technology analyzer, which is an automated way of comparing the base and target technology, identify the differences and the similarities between the base and target. Second in this process is the automated schematic porting software, which takes in the inputs from the technology analyzer, things like sheet rows, the unit caps, and also factors in various different limitations, CDF parameter limitations, and generates a schematic in the target technology with the same placement. Um, and the third in this portfolio is the design enabler, which is used in cases when the design needs to be bettered or when the topology of the circuit needs to be tested. And finally comes the semi-automated generation of the layout, which effectively addresses the base placement of the layout in a new technology, which effectively speeds up the time taken to generate a layout in a target technology. What you see on the slide are examples of time savings and hence cost savings brought about by the deployment of AMALIA IP reuse platform. So here we have cases of basic IP reuse blocks, which includes blocks like PLL, ADCs, and DACs. We also have examples of Wi-Fi's, Bluetooths, and GLONASS applications. As you can see here, using the deployment of this platform, we are able to reduce the design cycle time by about 50%. This is across multitude of technologies, multitude of nodes, and applications ranging from baseband all the way to high gigahertz. What you have here and in the next slide are testimonials from two of the companies with whom we are IP reuse partners of choice. The first one is Katina. These guys are now part of NXP, and with them we have worked on about 6 RF front ends, Wi-Fi's, and Bluetooths. And this is another partnership with an IP IP house, Dolphin Design, based in France. They specialize in PMIX and audio front ends, and we've been helping them move their designs into different technologies and different EDA platforms. To recap, at Thalia, we are bringing about a paradigm shift in the way analog IPs are reused. This is through Thalia's unique IP reuse platform called AMALIA, which is a combination of proprietary technology, methodology, and design expertise. We have a track record of working on applications ranging from baseband all the way to RF front end applications. We've delivered reduction in design cycle time up to 50%, and in the process, reduction to the cost of reusing IPs as well. We have a proven track record of working on a number of nodes and technologies, and we are happy to help you. So if you would like more information about how Thalia can help you in more efficiently reusing your IPs, please get in touch with us. Thanks for your time.